Hi, everybody. Thanks for coming to my talk. So this is about this whole journey I went on trying to come up with a replacement solution for displaying related stories on Princeton's main website, Princeton.edu. My name is Brian Osborne. I'm a solutions architect in the Office of Information Technology at Princeton. I work for a group called Web Development Services. We do lots of websites on campus. I think we have on our main site building platform, which is Drupal-based, around 1,100 websites. We got like departments, program centers, student sites, researcher sites, you name it, we probably host it. And I've been working with Drupal since around 2010, the Drupal 6 era, I think. I took a break for a couple years, but ever since then I've been doing mostly back-end development. But I've got lots of experience with JavaScript and front-end now. But Drupal's always been what I come back to. I have a mostly abandoned blog at bkosborne.com if anyone wants to read that. So Princeton.edu, it's our main, what we call like the core site or our flagship site. But it's got, the core of it, I would say, is news content. So stories about what's happening at Princeton, its impact, the community, and things like that. We actually have Christian Noble from the Office of Communications over here, if anyone wants to pick his brain later about the site. But WDS, my group in OIT, maintains the website for them. So yeah, there's 10,000 news stories going back all the way to 1999. So lots of content on the site to pull from. The way this works now on the site is all of the news is indexed using Apache Solr, using a hosted version of Apache Solr that Acquia provides for us. And Apache Solr has a feature called More Like This. And the way that works is it just takes the content of the article that's being viewed and it compares the content of that article with all the 10,000 other articles that have been indexed, and it tries to find content that is similar. The way it does that is a lexical similarity, so it's looking for keywords that exist in this article that might also exist in the other article, but those keywords have to exist. So yeah, we were looking for a replacement solution for this because Acquia was end-of-lifing their version of hosted Apache Solr. They call it Acquia Search. And they're moving everybody to another product called Search Stacks, and Search Stacks does not support this More Like This feature of Apache Solr. So we knew about this months ago, so I started doing research on what we can use to actually replace this. And most of my research pointed towards using semantic search. Semantic search is sort of a newer idea that's come about because of the proliferation of AI. You know, it seems like we would get better results from doing it too. And I'll get into a bit about why that would be. So yeah, I'll get into the topics here. I'll briefly cover these things. This is a fairly high-level conversation. I'm not going to get too in the weeds here. But I'll talk about how semantic search works, how it relates to related stories in my application, and how we can evaluate performance and improve the results. Okay, so what is semantic search? In essence, you're searching on meaning instead of on keywords. So it helps move past that frustration you might have in a traditional search application where what you're searching for, you're not getting results because the keywords that you search for don't literally appear in the article, in the title or the body of the content. That's lexical search. So it's looking for, the lexical search engines, they do have some trickery to make that process a little more intelligent, where they'll do like stemming of words. They have a big list of synonyms. So if you type in one word and there's like 5 synonyms for it, those will also be returned. But in essence, it has nothing to do with meaning. It's not interpreting context or meaning in the words. Semantic search is the opposite. It's doing all of that. A semantic search cares very little about actual keywords. It's trying to interpret, like, what is your intent with what you're trying to ask of the search engine, and it can understand that. Is it AI? Yes, it is AI, but it's not AI in the sense that everybody's been talking about lately, which is generative AI. But it uses AI concepts within computer science, like large language models and natural language processing and that sort of thing. So the best way to talk about this is to compare it with lexical. I'm going to have a couple slides on that to drive the point home a bit. So like I said, lexical, we're talking about exact word matches. It's not smart, but it is predictable and deterministic. So, if you're managing a search engine and you get reports about, hey, why is my department's page not showing up when people are searching for this? It's very easy to figure out why that's happening. And there's ways to fix that by saying, okay, I'm going to have a keywords field on this content that's maybe just accessible on the back end. It's not output on the page. But that keywords field, anything an editor puts in that, we're going to weight it like 20 times so that when Apache Solr is like determining, okay, what we should actually pull out of the search engine when someone searches for the word chemistry, the about chemistry page on this website, we're going to weight super high, so it's going to like lift up. You can do that sort of thing with lexical search engines because it's deterministic. There's like an algorithm that's very clearly you're able to follow to figure out why content is being surfaced the way it is. But like I said, it does struggle with synonyms and context. It doesn't understand meaning. Semantic search, much more forgiving for misspellings and things like that. So the way that people are talking to each other, if you're, your different tone in your speech, how that translates to text, that is all handled really well in semantic search. But it's not predictable at all or deterministic. So that could be frustrating if you're trying to figure out why something is being returned. And we'll get into some examples on that too. Here's a good example about where one excels over the other. And I think it's important to realize that like semantic search is not better than lexical search. It's just different. So you can see that here, if someone searches for something like fix something in my dorm room, semantic search performs strongly here if what you're trying to surface is the maintenance request form, because the keywords of what they searched for, while they don't appear in the maintenance request form title, semantically, those are the same concepts, right? Somebody's asking to fix something in their dorm room, they're probably asking for a maintenance request form. Lexically, that's going to perform pretty weak unless you've got really good keyword stuffing to figure out, like someone might be searching that, we should return this instead. On the other hand, if you're doing something where like you have a course catalog and someone's searching for a course number like MAT 101 for an introductory math class, you sort of want to do lexical there because you want that exact matching. A student knows exactly the course code that they're searching for. You might as well just do lexical matching and return exactly what they're looking for there. Instead of semantically, they might just get results that are generally related to math courses instead of that specific course number they're looking for. How semantic search works. Yeah, so this is going to get in the weeds a little bit, but this is as technical as I'll get. In essence, for this to work, we have to convert human language into numbers because that's how computers understand them, right? The way they're converted to numbers is using a large language model that's been trained on, like billions of pages, like the entire, we're all familiar, I think, at this point with how AI crawlers work, but they crawl the whole web and they consume all this knowledge and information about text. And these models are trained to understand meaning and recognize patterns in that text. And then when you feed text through a large language model that's designed to do this, to convert it to these numbers, it like passes that text through all sorts of filters to figure out what that meaning is in the words, and it converts it into numbers called a vector. A vector is just a mathematical thing where it's just like a big list of numbers. And in this case, so this example, if you were to vectorize, or it's called a text embedding in this context, but text embedding is just like the process and the output is a vector, an array of numbers. The numbers aren't random, like I said, it's basically understanding that it knows like apple and banana are closely related, but apple and spaceship are like in different zip codes. So it's taking that, and all of these numbers are in vector space. And I'll have an illustration or another slide to talk about that too, and an illustration to help drive it home. But so step one, you take the text of all the content that you want to index, and you feed it through an embedding model. And then you get back these vectors, these arrays of numbers. And then to do a search, you take the person's search query. So they're searching for when did combat start, for example. You vectorize that and you get the numbers for that. And then you take the two vectors, so you take the vector of what they search, and you take the vector of all 10,000 articles on the site, in this example, and you compare them mathematically using something called cosine similarity. And the result of that is a score, and that score determines how closely related those concepts are in those two things that were embedded. Everybody confused? Yeah. So this is a graph that sort of visualizes that. So a vector has many, many dimensions. So we can think about, like, this graph here is showing something in two-dimensional space. But vectors, in this sense, have hundreds or thousands of dimensions. And each of those dimensions can, like, sort of loosely correlate with what we would think of as an attribute about something. So, like, if something is like male or female, there might be a dimension within the vector for that. And if I go back here, each element in this array is a dimension. So I'm only showing 3 numbers here, but in reality, if you were to put this text through a text embedding model, you'd end up with probably around 1,500 numbers. So it's a lot of numbers that, taken collectively, represent the semantic meaning of that text. But in this example, if you were to draw a vector on a graph like this, and you were to vectorize the cat is on the mat next to the cat is sitting on the mat, the angle between those two vectors is very close, and that's what cosine similarity measures. And the closer those angles are together, the more closely related those concepts are. It is currently sunny in Phoenix is not related at all. The vector is pointing in a completely different direction. So it would not be ranked similarly to that text. Yeah, another way of thinking of this is a vector is just like GPS coordinates of where a piece of text sits in, like, a vast library of knowledge. All right, so how do we take that and apply it to related content? So basically, instead of having a traditional search query, we just use the entire article as the search query. So you're trying to find content that's similar to the article that's being viewed. Someone's not going to type in literally like a traditional, like, sentence of the search query. You just take the entire contents of the article. So first, like I said, we need to generate embeddings for all the articles, which means we need to convert the text of all 10,000 news articles on Princeton.edu into vectors. Then after that, we perform a search of the article being viewed against all the other articles, and we, like, take the top 6 closely related ones and display them at the bottom of the article. And then evaluate, okay, how can we improve this? There's lots of stuff and different ways that you can go about this to improve it. So the first step here to generate the embeddings, there's lots of different models, large language models you can use for this. The most popular one is out of OpenAI. It's called Text Embedding 3, and they have a large version and a small version. The difference really is the large version is a little bit more expensive and it's a little bit slower, but slower is 2 milliseconds difference in generating. Like, the latency is, like, it's not a big deal at all. Those are the popular ones. There's open source models that do this too. There's other companies that have text embedding models. And then getting API access, you can, in my case, you can connect directly to OpenAI's API, just sign up for an account with them. Or you can get it through, like, a reseller, like Azure. That's how I ended up doing that, because at Princeton we have access to stuff like that. So that was, like, my easiest route to get access to the APIs. And then the third step is prepping the content for embedding. So this is all coming from a content management system that supports rich text. So we've got HTML in there. You don't want to really feed all of the HTML junk into a text embedding model. You want to feed in just the text. Strip away all the stuff that is sort of noise. And another reason you want to do that too is it costs more money the more text you're feeding into a model. So you want to, like, just feed in just what you need. I actually iterated on this quite a bit because in the CMS, the content's being stored with like paragraph tags, divs, there's like list elements, there's image tags. Some of that does have semantic meaning, like paragraphs do. You want to preserve paragraph breaks with new line characters. And the way the HTML is stored in the back end, you might have to like do some interesting trickery with regular expressions and whatnot to make sure that you're capturing it consistently. So I went through a bunch of iterations on this, looking back and finding examples where like, oh no, if I strip it this way, then like the space is removed between two words. You have to be careful about that. And fourth step, actually feeding that in to retrieve the embeddings with the API. In my case, the model I chose with OpenAI, it's extremely quick to generate the embeddings, and you can do it like, I probably fed in 100 articles at a time. And the API response returned in like less than 100 milliseconds for that. So it's really quick. It's also really cheap. I think at the end of the day, with OpenAI's text embedding 3 large model, it costs less than $1 to do all 10,000 news articles, which is just like blew my mind, because it seems like such a powerful thing, but really the money for OpenAI is in like the more advanced models that people are doing for like chat interaction and coding. So then storing the vector somewhere. So you're getting back like this massive list of numbers. You have to store them somewhere. I developed this. The approach I took was like a proof of concept. I wanted to like do the least amount of work as possible to just prove this concept could work. And I figured out that you can just store the vectors in the key value storage in Drupal. It's going to use up a ton of space, but it's okay, just in my local environment. And you can brute force the next step, which is what I'll show you. So finding related articles. So an article is viewed, a visitor goes to the site, you want to find the list of related articles. What you need to do is you need to load all 10,000 vectors into memory. If you're doing this the way I did initially, which is brute forcing it. You load them all into memory, and then you essentially take the vector of the article being viewed and you loop through the vectors of all 10,000 news articles, and you perform the cosine similarity calculation on them, and you get your score, and you rank from there. That was extremely slow because I was doing this in PHP. It was not optimized at all. I think at one point I wrote a script to actually pre-compute the related articles for all the 10,000 articles, and that took like 4 hours. So there are obviously much more efficient ways to do that. Even in my like brute force method, where I'm not doing this with a proper vector database, I could have probably gotten it down to like, probably doing all 10,000 news articles within maybe 10 minutes or something, if I cared enough about that. But this was just a brute force proof of concept. Okay, and then next step after that would be improving results. So that's, I think, the most interesting part, and I'll get into some examples here. But there's like 4 things here that I was looking at. What to include in the embedding. So I've been up until now just saying embed the news story, but what does that really mean? News stories have titles, they have summaries, and they have bodies. Do you want to embed all of that? And when you do embed it, do you prefix the labels with what each of those things are? So you have like title, here's the title, summary, here's the summary, body, here's the body. Initially, I didn't even think of that, and I was just feeding it title, summary, body. And you can see how that might sort of confuse the model a little bit, because the title and the summary are very closely related, where the summary is just sort of an expansion of the title. But it's a little weird if you were to read it that way without knowing that, especially without having the semantic meaning of like on a web page, the title's an H1. It's very clearly distinct from the summary. If you're just feeding it as like paragraph to paragraph, it's treated as just a paragraph, so it might confuse things a little bit. Date cutoffs and date bias. So like I said, there's 10,000 news articles, they go back to 1999. Do you really want to surface articles from 25 years ago on the list of related stories or not? Then there's this concept of hybrid search I'll get into, and then re-ranking, which is really where it gets interesting. Okay, so first let's talk about full or partial body. So this is, do you take the entire contents of the article, or do you take just the title and the summary, or maybe just the title and the summary in the first couple of paragraphs of the article? And why is this even a thing? So if you were to take the entire contents of the article, the benefit of that is you're probably going to capture some nuance that's discussed in the article, some concepts that, while the headline is supposed to capture like, you know, the overall like impact and the meaning of the story, there's probably lots of interesting stuff in the story too that if you index and include in the embedding would probably surface some like really interesting related content. But on the other hand, you don't want to feed too much like so-called noise to the model either. There is a lot of like sort of fluff that's in the body of articles too that might not be what you want. So I did a little experiment. So this is an article about the university's librarian retiring. This is just a video this is what the article looks like on the site. Just so you can see, it's not a simple, like, okay, this person's leaving on this date. It's not like a couple paragraphs. It's about her like legacy at Princeton, right? Everything she's accomplished and things like that. So if we look at this headline, and on the left is the result of the headlines that surfaced as the top 6 related news articles if I were to index the full content of that article and all of the 10,000 other articles. And then on the right is or the opposite side is the partial. And in this partial, I think I just indexed the title, the summary, and I think the first 2 paragraphs of the articles. And the results are kind of interesting. I would say neither are great. And this is also, I use this as an example to sort of demonstrate also the weakness in semantic search over lexical search too. So we're seeing a lot of articles that are surfaced just about other people leaving, and people that have transferred either retirements or transferred to, they've retired as faculty. And is that, if you're reading a news article on the site, is that really what you want to see as related follow-up stories? Very likely not, right? You want to see stories about, okay, like maybe when was she hired as a librarian? What did you write about her then? Like what did you think her impact might be then? Something like that. Or stories about the library in general, right? I will say that I think the full body index was slightly better in that it's not just spitting out like literally here's 5 articles about employee retirements. These ones are a little more interesting, but they're still like of the same vein. I would say overall, I found the full body to be a little bit better than just the partial body. It's not always, I found several examples on Princeton.edu where really if you just capture the first 2 paragraphs of the text or even just the summary, it does miss out on a lot of good stuff in the body. And you're gonna get stuff that's not, it's like surface level related and that's it. You wanna kind of go deeper than that. The date impact cutoff was interesting. So this is a news article. This one was really fascinating. This is one of the most interesting articles I read on the site in a while, actually, Christian. Yeah, so this, I mean, there's so much history at Princeton. This was a really fascinating article about how New Jersey's legislature met in Princeton's historic Nassau Hall to like commemorate an anniversary of New Jersey. So lots of interesting stuff in this article. And what I wanted to demonstrate here is if you're doing a date cutoff or not, how does it impact the related stories? So if we don't do a date cutoff and we're asking the LLM to find related stories to this headline and the content of the article, it actually pulls up pretty interesting stuff. So you have articles here that are talking about the history of Nassau Hall and July 4th, like patriotic stuff, because, if you look up at the history of Nassau Hall, it was heavily involved in major events in the Revolutionary War and things like that. So lots of interesting stuff. The problem is, I think almost all the articles you're seeing were written like more than 10 or 15 years ago. So if we did a date cutoff of don't show any more articles older than 8 years, you get stuff like this. And there's lots of stuff about alumni here, which initially I was like, why are you surfacing stuff about alumni and reunions? Can anybody think about why that might be based on the headline of that article? Which is, if I go back, you can see in the bottom left.
Ceremonial session.
Return, right? So a lot of this article, the content, is about how, oh my God, it's so historic. Everybody's like returning to campus for this event. And what do alumni do every year? They return to campus, right? So like the semantic, like the overall big semantic impact of this content is like people returning to celebrate something, which is what alumni do, right? So, but on the surface, I'm not sure that that's a good connection to make. Like, I don't know. I mean, it's sort of a stretch. On the other hand, it seems kind of clever. But when you cut off all of the past stuff that it probably could have pulled from, this is what you're left with, and this is the best of what it could think of to give you, right? I say think like it's thinking, but you know what I mean. So this is just sort of demonstrating there's trade-offs to all of this stuff, and there's lots of tweaks and knobs that you can turn to change things a bit. Hybrid search. So I've been talking about semantic search and the way that you vectorize the content. So you take in the text and you convert it to a vector, the long list of numbers. Those dimensions that you get, there's like 1,500 dimensions. That's called a dense index. So meaning that 1,500 is dense. It's actually a small number of vectors. But you could also do something with a sparse index. And a sparse index might have hundreds of thousands of dimensions. But each dimension literally correlates with a word in maybe the English language. And the vector value is a 0 or a 1. So that's literally just doing like a lexical index of the content, but using the same technology that semantic search uses to store it in a vector. But all that to say is perhaps the best of both worlds here is to do a hybrid search where you're searching semantically and lexically, and you're somehow combining those results together. The benefit of that is there might be an important keyword in the article that would otherwise be missed by semantic articles or semantic search alone. I actually think that I thought this would be a really good application for news and a higher education website. A lot of the news articles are written about individual people, and that's like, proper nouns. You're talking about, you really want a strong signal for the lexical match of that person's name, or that building, for example, being named after somebody. Lexical, in theory, should perform better in that regard than semantic search. Unfortunately, when I was experimenting with this, I didn't see that at all. I didn't see any big improvement of combining the results. I tried all sorts of different things with algorithms to try to weight the scores differently. It is a little bit tricky to combine them because if you get a hybrid score from you don't just, there should be more nuance to it than just taking if I'm showing 6 top related articles, let me take the top 3 semantic and the top 3 lexical. There should be more nuance to that. You really want to combine the scores and weight them and then just take the top 6 of the combination. But I tried all sorts of different things. I didn't get really vastly different results at all. I sort of attribute that to 10,000 news articles sounds like a lot. It's really not that much, especially I think most of my experiments I was running at this point with a date cutoff in there because I think we had already established at this point that the editorial team doesn't really want to be surfacing this content that was written 25 years ago. We do want some level of a cutoff in there. But yeah, I didn't find a whole lot of difference with this. And then the last big thing here is re-ranking. This is really the most interesting. So up until now, there's lots of different ways to do re-ranking. One of them is to use a re-ranking model. And this is a specialized model that is really good at finding the fine-tuned similarity of text when you're comparing 2 pieces of text. And the vectorized search that I've been doing up until now is not doing that. It's designed to be extremely fast so that you can I'm doing a search against 10,000 news articles, but vector search is designed to be fast against millions of pieces of content. But the downside of it is it's not super accurate at finding strong relationships between content. So if you were to use purely just that and say, let me take the top 6 articles from just doing a basic vector search and doing cosine similarity on them, you'll get good but not great results. Pretty much every search engine that is doing semantic search is doing a re-ranking step after that. So instead of doing a query to find the top 6 articles from that first pass, they're doing a query to find the top 50. And with that 50, then they take the text, the raw text of them again, and feed them into a re-ranking model. And the re-ranking model is more expensive, it's slower, but it's much more accurate at surfacing these relationships between content. So I did that for this content. The leading model by far is something called Cohere Re-Rank. They just came out with a version 4 of their model, I think, at the end of last year. It is pretty expensive, but it's still within like our context of we're talking about 10,000 news articles, and it's not like we have to generate the list of related articles every day. We're still talking about like less than $10 a month. It's still extremely cheap. And I got through all this, and then I took a step back, and I thought, like, is that really what you want for related stories, though, on a news article? And I think not, because for related content, you're really thinking about recommendation engines, right? And you don't really necessarily want to recommend 6 identically similar articles to the reader, right? You want sort of a diverse offering of what you might want to present to them. And doing a traditional re-ranking model, like with Cohere Re-Rank, you're sort of making that less impactful. You're really driving home the point. And if I go back to the Ann Jarvis articles, this is why this happens. Because it is like, yeah, all of these articles about employee retirements are like really just about employee retirements, and they're very semantically similar to somebody leaving university, but that's not really what you want to recommend to viewers to continue reading, right? I will say that this project that I took on was initially like, okay, we have a deadline to get off of this Aquia Search product, which isn't going to support this feature anymore. So I was like, let me just find the easiest, quickest solution for now to switch to something that is similar in how that works. But there's lots of opportunities to make it better. But re-ranking, using this like re-ranking model is probably not it. Here's like 4 different strategies, really what we should be doing. So the top one is MMR, and from what I can tell, this is like the biggest bang for your buck. What you want to do is you query the vector database for like the top 50 articles, and then you go through them again. You pick like the one that's the most closely related. And then you take that one, and then you compare that one to the rest of the 49, and you find ones that are not related to it. And what you gain there is like, well, this article is related to the main article because it ranked in the top 50, but it is in some way diverse from the already one, like the one that we already selected. This is probably the next step of what I would pursue to get into to see how it might reduce this issue where you're just getting everything about employee retirements. Another option is we have 6 slots for related stories. Don't treat all slots equally. Assign tasks for each of those slots. So on the main site, we have like high-level categories for news articles, like is the article about news, research, faculty, etc. Categorize the content in the vector database too, and query for like the top related story about a student, top related story about faculty, top one about research, and assign each of those to a slot. That way you're like sort of forcing diversity in that way. So you're not going to get a list of 6 stories about employee retirements. Or even further, you can have an LLM do it, and instead of doing like 8 categories, have the LLM categorize it into like 200 or 400 categories, and go from there. And then you'll get sort of like an interesting mix, and you can say, okay, have a large language model say, find me like 3 articles that are like in the same cluster as this, but find me 6 more that are like in the same neighborhood, but not in the same like direct cluster. Use different strategies depending on the primary category of the article, right? So if the article is like a profile about a student's achievements or something, have a different algorithm that you use for generating the list of related stories there. Maybe you want to show other students' stories, but if the article is about like a research topic at Princeton, show faculty profiles of like interesting things faculty members are doing instead. I think that's a really interesting approach too. And then the fourth one is penalizing the results with near duplicate headlines. So this sort of goes into number one, but it's a little bit different. Where if you get results back that all have similar headlines, you could just evaluate how similar those headlines actually are, again, using LLM, and adjust the initial score of like the top 50 results to penalize the score. So like weight it down if the article is too closely related, the headline is too closely related to the main article being viewed. And then to move this up to like a production quality, using a proper vector database. So like I said, I stored initially for the proof of concept all of the vectors in Drupal's database, like key value storage. But that's silly. Like you really shouldn't be doing that because it's slow. It uses up a lot of space. They have hosted SaaS vector databases. PineConeDB is probably the most popular one. They have a free plan, which even for our use case on Princeton.edu, we could probably get away with using the free plan. It's very generous. But yeah, I mean, eventually that's what I moved to. So everything at this stage is hosted in PineConeDB. And the documentation for Pinecone is fantastic. The API is super simple to use, very straightforward. So yeah, moving it to a proper vector database. And when you do that, and when you go to query it, the results return almost instantly. It's like absurdly fast compared to my initial proof of concept, which was like 5 seconds to generate the list of related stories. Refreshing the embedding every time an article is saved. Yeah, so right now on Princeton.edu, the editors, they're drafting content and they're saving drafts. They're like building the story over time before it's finally published. But all until that time, the article isn't published. It's not indexed in Solr. And the problem with that is they don't know what those lists of related articles are going to be until they hit publish. So what they want is the ability to go in and say, like, okay, I'm ready to publish this story now. Like, what are the lists going to be? So in this solution, what we're going to do is start refreshing the embedding every time the article is saved and presenting the list of related stories right away in the draft mode. And then pre-generating the embedded stories in the background every month. This is like a pet peeve of mine, which is don't have a production app rely on communicating with a third-party API that and have that like interaction triggered by a visit to the website. So if someone is going to visit a news article and the caches on Drupal are cold, then it's going to make an API request to PineConeDB and possibly several API requests if we're doing re-ranking and things like that. And if that API is down or happens to be slow, now your web request is down or slow. And that can, cause serious issues. We've had issues with that in web development services in the past, especially on our other hosting platform, our multi-site one, because we're on shared hardware. It's a really big problem. So basically moving all this to a back-end job in cron and just like pre-compute the list of related stories and maybe do it like, depending on how expensive it is, maybe once a week or once a month. Part of the issue is like, do you, on one hand, compute them once and just leave it that way? Or if someone's viewing an article from 5 years ago, you probably want to surface like articles that were published after that too, right? And the only way to do that is to like recompute the articles every now and then. And this last step is manual curation with semantic backfill to empower the editors. We don't do that today, and I think they'll really like this. So basically, the editors currently have a choice for related stories to manually curate them and just select up to 6 that they want manually. Or they can have the system just generate the 6. But we should really just combine them, because there are cases where a news article, they really might want to surface some other related thing. I can think of something like a building being named for somebody. It's a really important thing. They want to surface the fact that that's somebody, like why they're so prominent. If they came to campus recently, they really want to be sure that other articles like surface so people can read about that too. take the guesswork out of it. Like, don't rely on the semantic search to like always get that right every time. Just let them pick it, and then like the rest of the slots they didn't pick, just backfill with the semantic data. Okay. Evaluating performance. So this is basically the end of the presentation, and I hoped to have gone further before this started, but this took a lot longer to figure all this out. But what I wanted to do is, there's lots of different strategies like I discussed on how to present the related articles, but I wasn't sure that I'm in the best position to decide which one is best. So what I did is I create this, that's working, right? Yeah. So this is an article, you scroll down, and it's like a little blind survey that people can fill out. So they go into view, and this is for like logged in people. We just invite like 10 people to go do this. And I just created tabs for like 6 different algorithms that were used for generating the related stories. I think in this case, one option is the existing solution with Solar, because I wanted to pit like the new semantic stuff against the legacy stuff that we're replacing it, because it would kind of suck if that is outcompeting this new solution we replaced, right? We want it to be like at least as good as that. The other 2 solutions that I ended up picking here were the only difference was you're indexing the full content of the article, and the other one is you're indexing just like the first couple paragraphs of the article and seeing which one is better or worse. The questions I ask, see if I can pause that real quick. The questions were tricky. I went back and forth on this quite a bit, but I wanted to know, of the 3 solutions, which ones do you think are acceptable? And which one is the best? And I didn't just want to ask which one is the best, because I feared like if people picked Solar as the best, that doesn't actually help me, because we can't use that solution, right? So I need to know like, okay, maybe Solar is the best, but is the other one pretty good too? So that's why they have the check boxes to say like, yeah, these 2 were solid, but probably this one was the best. And yeah, unfortunately, that's pretty much all I have, because that little survey thing I just got out like last week. So I don't have the results from that yet. I will say anecdotally from like my scanning of these articles that indexing the full body is better. And I haven't yet explored some of those things I talked about, like using MMR to like diversify the list of results. But I'm going to experiment with that, and that's probably where we're going to go with, because all of my research is pointing towards like that's your best bang for the buck. Yeah, I think I missed a bunch of things because I wasn't looking at my slide notes, but that's it. So, questions? Yeah.
Yeah, I'm curious for your MMR thing, if you considered one of the things that I find really useful is to have it try to give both an audience and also the jobs to be done that were probably, have it try to get the intent of what the user was trying to do when they came to the page to try to suggest.
Yeah. Yeah. So for the recording, you're basically asking like to help like re-rank and score with MMR, using additional data about the metrics of the visitors to the website, right?
You don't even have to use the metrics, although if you have access to the metrics, that might be helpful. But even just asking it, like, who do you think the audience is here? Like, you know.
Oh, I see.
Who do you think the audience is? What do you think the person was trying to do when they came to this page? Now, if you could have the access to the metrics, maybe you could inform that.
Right. Yeah.
It'll come up with some clever things even without that.
That is interesting. I hadn't thought of that.
Well, you sort of did that when you, in your third point in that slide where MMR was number 1. I think the third point was you were trying to infer the user's intent based on the category of the page.
Yeah. That takes it a step further. I think that is a good point. Because that's sort of what it is, but the categories that we're talking about are what the editorial staff have just generally said, this is what the article is generally about. Like, it's a faculty profile, it's about research, it's about this or that. Not necessarily asking an LLM what, like, if someone were to view an article like this, what might they be interested in seeing? What other types of categories of content? That's actually a really interesting idea. Like, feed it like a list of either like maybe 200 different topics that the LLM categorizes the content into, and ask the LLM, like, what other topics might be interested in surfacing for this? Yeah. Good.
First, I'm always so excited to see people not be afraid and just dive into something as complex as this that requires so much experimental, data-driven exploration. So I was just wondering, with that perspective, was, in your anecdotal findings, was it better than Apria Search and Solar's recommended articles?
Yeah. To be honest, I don't think it is better, but it's definitely not worse. And I think it goes back to the strengths and weaknesses. I found several examples where it clearly was better, but I also found several examples where it was clearly worse. So I think that it's all part of the balance of it. I was initially, when I first started researching this, I got like ridiculously excited. I'm like, oh my God, this is going to be way better, right? Because of course it makes sense to like look at the article, the semantics of it. But in reality, like the more like this feature, like before AI came around, there was a lot of effort in improving like traditional search engines, and they're like pretty polished at this point, and they're pretty solid at being able to surface like related content using lexical matching only. But I was honestly surprised. I thought it would be much better and like more hands off. But yeah, you do actually have to put a little bit more effort in and do like re-ranking. Yeah. Yes.
I'm curious, in your mind, how would you distinguish more like this from just search?
It's really not. It's mostly the same thing. Yeah, because I mean, more like this is just the search query is the entire content of an article.
Well, I guess you're not doing a chunking pass, which is what I would think of you doing in a kind of RAG search system. It seems like more like this or related content. It's less about the query. It's not clear what the user's intent is, because the user's not using natural language to frame the question. Instead, you're using like the title plus, some of the body to do the more like this.
Right. No, that's a good point, because it's not right. It's not phrased as a question, as it would be otherwise. But I think in a traditional vector search, it doesn't matter. It's trying to find the meaning of something regardless. If someone's asking a question, it's still like, what is the concept of, like, what are they really getting at? And the same thing with, if you take the whole body of an article, it's like, what is the essence of what they're saying? I think ultimately it doesn't matter too much if it's phrased as a short question versus like a whole body of content. I could be wrong about that. Yeah.
Are you like the examples you showed was the related content, but are you also looking and testing it out on the search side? Because that's where I would expect to potentially see more difference.
So on Princeton.edu.
Where you're wrong.
Oh, for sure.
Where your intent is discernible, but your actual terms were incorrect.
I will say that I would expect, so the search engine here for news, this is still using Solar. And our goal here, I think, is to swap this with semantic search too. And in this application, I'm almost positive it's going to be better than what we're getting right now. Because this is still relying on keywords. And for a short phrase, I think you're going to have much better results with this. I think that semantic for just finding related content is the trickier issue, and you have to spend a lot more time rescoring the initial set of results. Whereas here, I would get the initial 50, and putting it into Cohere to re-rank it, I'd probably get like exceptional results, because you really are looking for something here that's super closely related to the query. Whereas related stories, not really. You want a diverse set of options, but diversity wouldn't really help you too much here.
Brian, maybe I can just mention and ask a bit. You mentioned one important thing, that with this mechanism, you are like, in a way, like steering your auditorium, in like who's reading these articles, because as you mentioned, like if you are showing the articles that someone was leaving organization, then it will just stay within that bubble for the next searchers with recommendations. But in this sense, like the search algorithm, does it have any like parametrical thing like intent? Do you want to keep people in the bubble, or do you want to give them like other attitudes?
No, it doesn't. It doesn't. So because my initial search is just doing like a vector search using cosine similarity, you don't have the opportunity to say that. Ideally, you could say like, okay, based on the results you return, give it instructions like you would to like a chatbot, right? Give it additional context about what you want. It doesn't work that way because to make this super fast, it needs to be able to have like vectorization of all the content already, so it can do the mathematical comparison really quickly just to find the closely related ones. That's when you have to do re-ranking. So all of the search engines and the chatbots, they're all doing re-ranking to figure that out. So they're getting like an initial like 1,000 related things that it thinks are in the ballpark of what the user's asking for, and then it does all sorts of different re-ranking algorithms to figure out what they really are asking for within that set. But yeah, I was always hoping for that. And really, I feel like that's a good opportunity for like some SaaS company to come out with something like that, to just make that stupid easy to do.
Yeah.
Like just like, yeah, let me feed some context and have that inform what's returned as a result. And maybe that already exists, I just haven't found it yet. Yeah.
Thanks.
Yep. Joe?
Are your content editors forced to put tags in, and are you accounting for the categories and those tags in your overall?
Yeah. They are forced to do it. They have to select at least one, but I think they can tag it multiple items.
Are you ranking those higher?
I'm not, yeah, but that is another strategy. Yeah. A lot of this is, like I said, I was hoping to have this done before the presentation to like figure all this out, but I just sent this over to the Office of Comms like a week ago, and so they have to give me like feedback first and then go from there, because we're also cost recovery, so I have to be like, how much do you want me to spend on this, like finding like better solutions, you know? Yep.
When you were talking about re-ranking, the first thought that popped into my mind was asking an LLM to produce key tags and people and topics and a summary that highlights the most unique aspects, and then comparing the distance.
Yes.
between those.
Yes, and that's what number 2 is here. The 2A. That's what 2A is describing here.
Okay.
It's you're asking an LLM to take all the content and come up with like 400 key topics from those things, and then vectorize those, right? And then you get, all right, so this, I know that this article being viewed is tagged from the LLM from like these 7 key topics. Find me, for the 6 slots I'm showing, find me like 3 that are in the same neighborhood, but let's find like a diverse set too, from like they're in the ballpark, but like they're, you know, then they're still like somewhat related, but they're diverse enough that it's like interesting. I mean, if you go to like YouTube and you watch a video, it's not showing you for recommendations everything that's like identical topic, right? Because that's not interesting. That's not how you drive engagement. So that's really where this should go.
Well, YouTube has data on clicks.
Yeah.
So they start with that and then they re-rank based on
Yeah. Yeah. If only I had the resources of Google. Yeah.
Can the search results assimilate different content types? Like events and people? And...
Yeah, they certainly could, but on Princeton.edu, it's just news. Yeah. And we offload, like if someone were to do like a general search on Princeton.edu, we offload that to Google actually, because we have like 1,000 websites, right? Or more, 3,000. So we assume that if you go into Princeton.edu and you do a search, you don't just want to see stuff on our main website, which is mostly a portal to other websites. You want to search PPPL, for example. So, yeah. All right. Thank you.
Thank you.